Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at intersections of circles and straight lines. We can see here I've got a circle and I've got three straight lines. Okay, here's my axes, we've got a circle, and actually, just for a little bit of information, there is the centre of the circle. The centre is at the origin. Okay, we've got three straight lines. I've got a red line here, I've got a blue line, and I've got a green line. Okay, now these lines actually sort of continue forever and ever like that. Okay, I'm just showing a little part of the straight lines. We've got three straight lines because there is three kind of situations, if you like, for an intersection between a straight line and a circle. Okay, let's first of all have a look at this red line here, and we're going to have a look at the intersection point, which is about where that yellow dot is. Okay, there's only one intersection point here, so I'll do some annotation in blue. We have one intersection point, and it's where the yellow line is. Okay, and it's one intersection point between the straight line and the circle. Okay, it's there. Now, if you recall, we've got one intersection point. So at GCSE, if we've got one intersection point, we've got a circle and a straight line with one intersection point. That is a tangent to the circle. So this red line here is what we call a tangent. Okay, that red line is a tangent to the circle because it only intersects the circle once. Okay. Let's then have a look at the green straight line. We've got a different situation here. We've got the straight line intersecting there and there. Okay, we've got two intersection points here. So let's write that on the green line. We've got two intersection points. Okay, and with two intersection points, if we were to just have a look at this part of the line, just connecting those two intersection points together, that part, and I'll highlight here, is called the chord. Okay, that's just a little bit of extra information for you, but there we've got two intersection points. Here we had one that made a tangent. Here, just that grey part of the straight line is called the chord. Okay, or a chord. So there's one intersection point. The green line is two intersection points. Let's have a think about the blue straight line. And we can see that, let's say I have an intersection point here. Where can I put this intersection point? You know, if we think about the straight line continuing, let's extend the straight line a little bit, okay? Where can I put the intersection point between the circle and the blue line? Well, nowhere, because there are no intersection points, okay? The straight line is just going to continue all the way up here and continue all the way down here. It's never going to intersect the circle because the circle is just that circle there, okay? So it's never going to intersect here. And there's not just one straight line that it's never going to intersect. It's never going to intersect this straight line. Okay, it's never going to intersect that straight line, and it's never going to intersect that straight line, or that straight line, or that straight line. Okay, we can see, because let's just look at this straight line. It's going to continue all the way down here, and it's going to continue all the way up there, never going to intersect the circle. So let's just go back to looking at this one blue line. I'm going to write on here, and in fact we'll go back to it being a little bit smaller. I will write on there that there are no intersection points. Okay, and we don't have a name for that, it's just a straight line that has no intersection points. Okay, so those are the three situations. We were tangents, we have two intersection points which will make, when we connect them two together, make a chord, or we've got no intersection points. Okay, let's have a look at the first example for this lesson. So, we want to find the coordinates of the points where the line y equals x plus 5 meets the circle x squared plus y minus 2 all squared is equal to 29. So hopefully from the previous video you can recognise this equation of the straight line. what's the centre of this circle going to be? Just have a think about that. Even if it's not part of the video, or the question, sorry, it's always useful to have a think about that. And all of our questions are always going to be grammatically correct. So we're being asked to find the coordinates of the points where the straight line meets the circle. So we're going to have two intersection points here because it's plural, we've got points. Okay, so what can we do? Think about it. Maybe think about simultaneous equations. Can we substitute the straight line into the circle to work out the intersection points? Well, yes, you can. So have a go, press pause, and when you're ready, press play and we'll work through the answer. Okay, let's see. So, like I said, you can substitute this straight line into the equation of the circle. When we do that, we're basically setting them equal to each other, so that will give us the intersection point. Okay, so what I'm going to do is I'm going to, wherever I see a y in this equation, I'm going to replace it with x plus 5. So let's substitute. That's not how we spell it. Substitute, that's much better. Okay, let's substitute. So we are going to have x squared plus y, I'm going to replace with x plus 5. So we'll have x plus 5, let's highlight that in yellow, that's my substitution. Then we've got minus 2 squared is equal to 29. Okay, that's what I've done when I've substituted. I can simplify that a little bit to give me x squared plus x plus 5 minus 2 is plus 3 squared is equal to 29. Okay. Right, what can we do now? Well, I need to solve for x because I want to work out the intersection points. So I'm going to expand the bracket. So that's going to be x squared plus 6x plus 9. Let's check that's correct. It is equal to 29. Okay. Then what we can see is I can collect like terms. I've got 2x squared here. So 2x squared plus 6x, and I'm going to take off 9 from both sides to give me 20 there, okay? And then I'm going to solve the quadratic. So I'm going to have 2x squared plus 6x, and I suppose you could have taken 29 over this side straight away to give you minus 20 is equal to 0, okay? The maths just works a little bit nice if you take the 9 over to the 29. Okay, so now we have that. I'll divide by 2. X squared plus 3x minus 10 is equal to 0. And that does factorise. Hopefully you're able to factorise. I'm going to take it from the book. That gives me x plus 5 times x minus 2 is equal to 0 when you factorise. Okay, so either bracket can be equal to 0. That tells me, and I'll go straight to x is equal to minus 5 or x is equal to 2. Okay, now we were expecting two values of x. In terms of the maths, we were expecting two values of x because we had a quadratic. Okay, so we're going to get two brackets to give us two values of x. But we were also expecting two values because we said, or we were told, points. Okay, so then we said, okay, we've got points. So looking back up here, we're going to have two intersection points. So in other words, we're going to have two x values. So those are my two x values. And then we need to work out the y values. And to do that, all I'm going to do is then substitute each of those x values, or those x coordinates, to find the y coordinates into this straight line. Okay? So let's do that. Let's substitute each x value into y is equal to x plus 5 to find the, and we'll put corresponding y values. Okay, so when x is equal to minus 5, y is equal to minus 5 plus 5. Y is equal to 0. Okay, and then when x is equal to 2, y is equal to 2 plus 5, which is 7. And so the intersection points and we can just take, there's my x, there's the y, so the intersection point -5, 0, and there's the x, and there's the y of the second intersection point, 2 and 7, are the, I'll shorthand this, POIs, points of intersection, okay? Because that's what we were asked for, the coordinates of the points where the line meets the circle, okay? So we'll highlight that in yellow. Those are the points of intersection, okay? So hopefully that makes sense. Let's have a look at the second example, and I think it's the final example for this video. It is. All right, so it says show that the line y is equal to x minus 7 does not intersect the circle x plus 2 squared plus y squared is equal to 33. Okay, so this time we're being told that there is no intersection. We're saying this line does not intersect the circle. So in terms of a graph, if you want to picture what's happening, we've got a straight line like this blue one in the example that we started with. There's no intersection point. If, like I said, I was going to put my intersection point, there's nowhere I can put this point that is on the circle and on the blue line because there's no intersection point, okay? Let's just delete that. So we need to prove that that's the case, show that. So all I'm going to do is I'm going to substitute, a bit like we had an example in the previous video, I think. We need to substitute this equation of the straight line into this circle and then show that this right-hand side is not going to be 33, or that the right-hand side is not going to factorise nicely to give me intersection points, basically, okay? So let's substitute in. Pause and have a go if you want to, and then we'll work out the answer first, actually. Okay, hopefully you've had a go before me. Let's see what we can do. So, like I was going to say, substitute into the circle. We'll do that, and we'll just do that straight away. So, wherever I see a y, I will substitute it for x minus 7. So, I'll have x plus 2 squared plus, well, we've got a y there, so I'll replace that for x minus 7 squared. That's going to be equal to 33. And by the way, actually, the centre of this circle, just to see your knowledge from the previous video, is -2, 0, and the radius we'll call r is root 33. Okay, we've got that from taking the opposite sign here, -2. We've got nothing being taken away or added to the y, so it's 0, and the radius is that square rooted. Okay, let's get back. So we'll expand this now. So we'll have x, oh, let's do it in black. Yeah. We'll have x squared plus 4x plus 4, I think. Let me just check. Yes, that's correct. And we will add to that, expanding the second bracket, x squared minus 14x plus 49 is equal to 33. Okay, then we can collect like terms. I've got 2x squared there. The x's, I've got a 4 and a minus 14, and then my constants, I've got 4, 49, and 33. Okay, so I've got 2x squared, I have got minus 10x, and then my constants are going to add to give me 20. Okay, I've got 4 plus 49, and then take off 33 gives me 20. Okay, take off 33 because then we've got the right hand side to be equal to 0. Okay, so then I'm going to divide by 2 to give me x squared minus 5x plus 10 is equal to 0. And then we can think, right, are there going to be any solutions to this quadratic? And if we think back to the discriminant, we can use the discriminant to help us. Now, the reason I go to the discriminant here is not because I've just plucked that out of thin air. It's because we are trying to prove that there is no intersection point. So in other words, there's no solution to this quadratic, okay? It doesn't make sense when we substitute it for this right-hand side to be equal to 33. When we move everything over, we get this quadratic equal to 0. Because there is no intersection, this is the quadratic of the intersection point because we've done a substitution, okay? This is the quadratic that we come out with. There's no intersection point, so there has to be no solutions to this quadratic. because it doesn't make sense for there to be solutions if there's no intersection, okay? There's no intersection, so there's no solutions of this quadratic. So think back to quite a few lessons ago, think about the discriminant. The discriminant will be less than 0 if there is no solutions to this quadratic. The discriminant, if you cannot remember, is the part under the square root of the quadratic formula. It's, well, there's the square root. The discriminant is this part here, b squared minus 4ac. That's the discriminant. Okay, so let's work out b squared minus 4ac, and to prove that there are no intersection points, we want to prove that b squared minus 4ac is less than 0. Less than 0 implies no solutions, okay, which implies no intersection point, and that's what we're trying to prove. No intersection between the line and the circle, okay, because this quadratic, like I said, is the result of the substitution between the circle and the straight line. Okay, so let's work out what b squared minus 4ac is. A is going to be the coefficient of x squared, which is 1. B is the coefficient of x, which is minus 5, and then c is the constant. We'll just show where those have come from. There's our invisible 1, there's our minus 5, and then there's our constant of 10. Okay, so let's substitute. B squared minus 4ac is going to become minus 5 squared minus 4 times a times c, which is 10. Minus 5 squared is 25. Minus 4 times 10, that's going to be 25 minus 40. And then I'm not really bothered what that is. We can clearly see that is less than 0. Okay, so that means there are no solutions. We said it's less than 0, so there are no solutions. Hence, no intersection points between a straight line and the circle. So therefore, we have shown that what the question wanted us to show. Okay, we've shown that the discriminant is less than 0, so we've finished the question.